Hi everyone, this is just an extra PowerPoint on the bivariate investigation, just addressing the causality versus correlation part of the assessment. So when we are looking at our associations, we are talking about whether they have a relationship, but we don't actually know whether the relationship is caused by the independent variable or whether it's just that the two variables are related. So I think it's really important that you understand this part of the investigation so you can talk about it in your conclusion. So here's an example. A scatter graph shows a strong positive linear relationship between the number of firemen at a house fire and the amount of damage done at the house. Does this mean the more firemen, the more damage? Does this mean that more firemen cause more damage? Is this correlation or causality? So we'd have to think about this and say, okay, what kind of things would cause there to be more firemen? So a bigger fire, a bigger property. Yes, a bigger property, more damage. So a lurking variable is something that's in the background affecting what's going on, but not one of the variables we're investigating. So the size of the property could be a lurking variable here. It could be part of the cause for these two things to be correlated or related. Okay? So in your conclusion, you might want to summarize all those things that we've talked about before, the relationship between the data, the appropriateness of the model, but you can also here talk about correlation and causality. So how ice cream kills. There's a little video here. I'm not going to show that on here. I will show it in my classroom. There is a strong correlation between a child's shoe size and their ability to spell. So if you could measure these in some sort of measure and put them on a graph, they're going to show a strong positive correlation. In other words, as the child's foot gets bigger, they get better at spelling. But you can see that obviously it's not the foot size that is affecting their spelling. It's the lurking variable, the fact that the child's age will probably be affecting both of these. As the child grows, their foot will grow bigger, and they'll usually learn to spell better. So a lurking variable is a variable that is not in the data set, but is associated with the changes in both the other variables. So there's another little example here of high number of drownings and high ice cream sales. Then they probably have quite a strong correlation only because the high temperature means both people would be buying ice creams and people would be swimming to cool down. Okay, so hopefully that can help you with your conclusion, and yeah, good luck.